Okay, so at this point we have talked about how to draw electron flow to make new bonds and break old bonds. But we really haven't talked about how to predict acid-base equilibrium. So what we're going to do is try to do a very quick refresher on what acid-base equilibria actually means, and then we're going to try to apply, pKa's to try to predict equilibrium. So really quickly, going back over what acid-base equilibrium actually is, we're going to try to display this in a pictorial form. So we're staying completely away from atoms just to make sure the point comes across. So for this picture, what we have are two sets of possibilities. You have this kind of magenta, blue, and yellow dot, and you can have them combined in different ways. So you could either have a combination where a magenta and blue dot kind of combine together to make an item, or you could have this alternate possibility where the blue instead combines with the yellow, and then you have a new item. So you could either have a blue magenta item, or you can have a blue yellow item. These are two totally different items, and you can just combine the different colored circles to get different combinations. So when we talk about acid-base equilibria, we can use this very simple colored circle analogy to talk about what we mean. So we could either have a couple possibilities here. We can either have these circles, as they're going along their merry way, they can combine in a lot of different ways. You could have them combine in one situation where you have maybe 50% of the blue, magenta, and 50% of the blue and yellow combined. And in that case, if we were to talk about equilibrium, we would say that there would be an equal equilibrium between these two states. So 50% of the time we have this on the right, and the other 50% of the time we have the other scenario on the left. So this is one way to talk about equilibrium. If we were to draw these arrows slightly differently, if we were to draw them maybe like this, we would say that for whatever reason, this blue and magenta configuration would be a little bit less favorable than the blue and yellow. So what this might mean is that, I don't know, just kind of random numbers, 25% of the time, we might have this blue and magenta, versus 75% of the time we might have blue and yellow. Okay, and then if we were to even do one more, we would say then, well, we could change the equilibrium in one other way, and that would be if we erase this little arrow on the top. And that would mean pictorially that if we have this possibility of going back and forth, for whatever reason, the blue and magenta might be slightly favored over the blue and yellow. And so in this case, we might have a higher percentage of the blue and magenta combo, and smaller percentage of the blue and yellow combo. And that's in essence what equilibrium is. All it's doing is trying to describe which combination is the most beneficial or the most stable